Second derivative test. Let f be a function such that the derivative of f of c equals 0, and the second derivative of f exists on the open interval containing c. Number 1, if the second derivative of f of c is greater than 0, then f has a relative minimum at c comma f of c. Number 2, if the second derivative of f of c is less than 0, then f has a relative maximum at c comma f of c. If the second derivative of f of c equals 0, then the second derivative test fails. That is, that f has a relative maximum, relative minimum, or neither. In such case, you have to use the first derivative test. So first of all, let's look at this guy. This states if the second derivative is greater than 0. If that is the case, then right here, if this is function f, then, and if this is c right here, at f double prime of c, this would have to be greater than 0. This is concave up. Okay? If that is concave up, then this has to be a relative minimum. Same argument can be made for number 2. Hopefully that makes sense. Let's look at an example. Let's try the second derivative test here. So we want to use the second derivative test to find the relative extrema, to find the relative mins and maxes. So first of all, we're going to find the critical numbers. To do that, we're going to take the first derivative, which would be negative 15x to the fourth plus 15x squared. Then to find the critical numbers, first of all, we take the function, set it equal to 0, and find the x values that would make this true. So I can factor out negative 15x squared, leaving me with x squared minus 1. So this would equal negative 15x squared. Difference of squares here, x minus 1, x plus 1. So when x is 0, or when x is 1, or when x is negative 1, this would equal 0. To try to figure out the x values where this derivative does not exist, that doesn't come into play here. Since this is a polynomial function, the domain is defined everywhere for the derivative there, so there's no x values that would make the first derivative does not exist, so that doesn't come into play. Remember that the domain of this function is all reals. Alright, so we have our critical numbers right here. Next, let's take the second derivative. So take the derivative of the first derivative, and right here, and this would be negative 60x to the third plus 30x. Okay? And then what we can do here is we can do a number line here. So the domain here is all reals. Critical values are at -1, 0, and 1. So we have an interval from negative infinity to -1, -1 to 0, 0 to 1, 1 to infinity. Okay? And what we're going to do different here, we're going to test this point here. Because if we're able to figure out the second derivative of -1, we can figure out whether, at that point there, whether it's going to be concave up or concave down. And then we can determine whether it's relative min or max. If you can apply the second derivative test. If it equals 0, then you can't use it. So, when I plug -1 into this, -1 cubed is still -1. So this is going to be 60 minus 30. That's going to be positive, so that's going to be greater than 0. So this would be concave up. So we have a relative min at x equals -1. Next, let's test f double prime of 0. If I plug 0 into this function, this would be equal to 0. So this means second derivative test fails. So then we got to go back to the first derivative test for that one. We'll come back to that. Next, this one, we're going to do f double prime of 1. So this would be -60 plus 30. That's going to be less than 0. Okay. So this is going to be concave down, which means we have a relative min at x equals 1. Now we got to come back and look at this part of it to figure out what's going on here. So we're going to go back to the first derivative test. So first of all, I'm going to look at this interval here, and I need to test f prime of, let's do -1/2. So here's the first derivative, so it would be -1/2 equals -15, -1/2 to the 4th, plus 15, -1/2. So let's see, this would end up being positive 1/16. This would end up being positive 1/4. So then we've got -15/16 plus 15/4. So this is greater than that, so this is going to be positive. So this is going to be greater than 0. So this is going to be, the slope is going to increase here. Then we need to do the same thing over here. We need to do f prime of positive 1. This is basically going to be the same. Okay, if I put positive 1/2, positive 1/2, that's going to be the same here and there. this again. So this is going to be an increase as well. So if the slope is increasing and the slope is increasing here, this is not a relative min or max. So it would just be nothing there. And there we go.